We propose Telextiles, an interface that can remotely transmit tactile sensations of textiles. When a user touches a textile with the input device, the roller rotates so that the textile with the closest properties is in front of the other user. We use contrastive self-supervised learning to obtain a latent space that takes into account the proximity between textiles. By reflecting the latent space, users can simulate the tactile experience of any garment online. Our main contributions include the following: latent representations based on self-supervised contrastive learning considering the proximity of textiles. This enables even fabrics not used in training be represented in relation to the available fabrics. Apparatus for user-independent, stable tactile sensing of textiles, created by combining an optical tactile sensor, Digit by Facebook AI, with a custom jig. A roller-type actuation device that presents a textile that is in the closest proximity to the transmitted textile sensation. We can apply this system to online shopping and remote collaboration in the fashion and textile industries. Users can simulate the tactile experience of the garments online. We can also visually see how close the sent tactile information is to the existing textile. System configurations are as follows. Our system can be divided into two phases: a training phase, which is performed in advance, and a tactile transmission phase, in which users actually transmit the tactile sensation of the textile. The training phase is assumed to be performed by the manufacturer, who learns encoders to extract a latent vector representation of the tactile sensation from a large sample of textiles. The transmission phase is performed by two remote users, A and B. User A acquires tactile data by pressing a tactile sensor against a textile. This tactile data is sent over the network to the server. Using the learned encoder, the server extracts latent representations from the transmitted tactile data. The server then computes the closest training sample to the transmitted data in latent space and sends the raw latent vector or the ID of the closest sample to user B. User B can confirm the received tactile sensation through visual or tactile feedback. To determine whether the model could assess the similarities between fabric combinations as accurately as those perceived by individuals, we conducted a user test. We compared the similarity judged by the human and the similarity judged by the model. The result was that the encoder's choices did not match the human subject's choices enough, and there is room for improvement. One possible reason for this is that humans seem to take the sense of friction into account, while the system does not. The miniaturization of our actuator could change the way we interact with the world, allowing for more immersive experiences in remote communication and teleoperation scenarios. If such miniaturized actuator develops, such as wristwatch communication devices and fingertip sensor devices, the actuators can be expected to replace the current roller-type actuators. This concludes our presentation. Thank you.